this is Austin from The Body Curious, and today I'm going to be talking about spacecraft and light. Why is this important? Well, it's connected to fascia. And the reason I talk about this is that there are different schools of thought around fascia, and it's not that one is wrong and one is right. I just have a particular approach that I think is important to think about, is that unlike muscle, fascia reacts like a non-Newtonian fluid. In other words, the more pressure you put on it, the harder it gets. And actually, the demonstration we use is cornstarch, is that if you whip up some cornstarch, and if you hit it really hard, it actually becomes a solid, but actually if you go slow into it, you can actually put your fingers all the way in. And this is an analogy for how fascia works. I look at it as approaching it low and slow. We talk to fascia, we don't shout at it. And this is also a play on words because we talk about talking this direction also. So what's this connection to do with light and space? Well, I was looking into the very first object that ever left the solar system, and this was the Pioneer 10 spacecraft that was originally sent out to take pictures of Jupiter, and it left the solar system, and its last transmission was back in 2003, and its power source at launch was only 155 watts. So obviously from all that time it was travelling, 7.6 billion miles I think it is, until we last heard of it, the power was gradually going down, and yet we had a transmission 7.6 billion miles away from this little thing that's little better than a small light bulb, and we were able to gain information from it. And this is this idea of resonance, is that you don't have to have a large power source to get information. And this is how I see fascia, is actually approaching it delicately, and we know this in research, that actually fascia responds to something called the 6 dyne. A measurement of dyne is 1 dyne is 1 gram of pressure and being able to move it 1 centimetre in 1 second, and fascia responds optimally, as far as we know, at around 6 dyne. That doesn't mean to say it doesn't respond with higher pressure, it just means you actually get the best out of the receptors and you get collagen realignment. So my rule of fascia is actually low and slow, and think of it like the Pioneer spacecraft, is just because it seems extraordinarily far away, actually you can actually still get an effective response with very, very, very little power. So think about that when you're next working on fascia. You don't need to go in there hard and fast like some people do with regards to muscles, is that actually you can actually get more out of fascia and a greater response actually when you're approaching it low and slow. And this is something that, if you've been trained in physiotherapy, this is kind of hard to get your head around, is that quite often we think of if we go in deeper, we're getting more out of it. And when it comes to fascia, the reverse is true. There may well be reasons to go in deeper. That doesn't mean to say faster. And when it comes to fascia, really, the slower we go, we can actually get deeper, the slower and gently we go. So this is Austin saying, tune in next time. Cheerio, bye-bye.